Hello, Algebra 2 students. This is lesson 52. Our objective is how do you solve quote-unquote simple mixture problems? And we call them simple not because they're simple to solve. We call them simple because they can get a whole lot more complicated than this. So pretty much the main idea is you're going to have two different solutions. You're going to have, I'm calling it solution X and solution Y, that has some percentage, I don't know, maybe alcohol, maybe sodium, maybe some percentage of water. Who knows? It just depends on the word problem there. We have two different mixtures that you're trying to mix together into a new solution, and you're trying to find out how much of each of those solutions you should use to have a total amount. Like they'll give you a total amount, like, oh, we need to have so many milliliters, and they need to have a certain concentration in that new solution. So you're trying to mix those two to come up with a new one with a certain percentage. So the basic idea of what you're going to do is you're going to set up a system of equations that has two unknowns. Now normally those unknowns are this amount, how much of each solution you should put in. And you will want that to equal z percent, the decimal version of your total percent, times the total amount of solution that you want. All right, so these percents mixed together should equal that percent of the total. Then you'll want to say each of those amounts that you find will equal the total amount that you're looking for. Then once you have those two equations, your basic idea is to then solve them. You can use any method that you want that we've learned so far. We have talked about solving those by graphing, by substitution, by elimination. You can do any of those. There's also matrices and a few other methods if you want to do those. So really just whichever one makes you happy. So let's go ahead and try a few of these. Alright, so it says a druggist has one solution that is 10% iodine, another that is 50% iodine. How much of each solution should the druggist use to get 100 milliliters of a mixture that is 20% iodine? So let's set up an equation here. I'm going to call this one S sub 10 and this one S sub 50. So to get my first equation, I'm going to multiply this as a percent, so 0.1 times my first solution plus 0.5 times my second solution, and that should equal to 0.2 of my total amount of solution, which is 100. So 2% of 100. Which would just equal 20. Then my second solution would be however much I use in my first one plus however much I use in my second one should equal to 100 milliliters. That's what my goal is. So I'm thinking I'm going to use elimination to solve this one, because I'm noticing that if I multiply this one by 10, have the same coefficient here. So I'm going to multiply this whole first equation by negative 10 so I can add them together and eliminate my S sub 10s. So I'm going to multiply this equation by negative 10, and I will get negative S sub 10 minus 5 S sub 50s and equal to negative 200. Rewriting this equation over there, end up with S sub 10 plus S sub 50 is equal to 100. Whenever I add those, these two equal to 0. This would be negative 4 S sub 50s is equal to negative 100. Whenever I divide by negative 4, I get S sub 50, how much I need of the second solution, to equal to 25 milliliters. Okay. So again, that's half my solution, because I also need to find out what S sub 1 or S sub 10 is. But remember that S sub 10 plus S sub 50, this equation, is equal to 100. So subtracting 25 from both sides, S sub 10 is equal to 75 milliliters. So to answer your question, you say I need 75 milliliters of the S sub 10, or the one with 10% iodine, and you'd need 25 milliliters of the one that's 50% iodine. Let's try one more of these. A chemist has one solution that is 10% salt and 90% water, and another solution that is only 2% salt. How many milliliters of each should the chemist use to make 140 milliliters of a solution that is 6% salt? So again, let's set up our solution here. It's going to be 0.1 times this solution they're talking about. Let's call S sub 10. This one that he's talking about, let's call S sub 2. So I'm going to say S sub 10 plus 0.1 S sub 2 is equal to, I want 6%, so it's going to be 0.06, and actually it's only 2% salt. I'm not sure why I put that 10 right there. Should be 0.02. And then this is going to be times that 1,400 milliliters there. Our next one's going to be S sub 10 plus S sub 2 is going to equal to 1,400. So let's see. I may just go ahead and solve this one by substitution. So I'm going to say S sub 10 is going to equal to 1,400 minus S sub 2. I'm going to substitute that into the top equation. So 0.1 times 14 minus S sub 2 plus 0.02 S sub 2 is equal to 84, and that's just multiplying those two numbers is how I got that 84. Sending this in, it's going to be like dividing by 10, so it'd be 140 minus 0.1 S sub 2 plus 0.02 S sub 2 is equal to 84. I will subtract 140 from both sides and combine those two together. Gives me negative 0.08 S sub 2 is equal to negative 56. I'll divide by that 0.08, the negative of that. And obtain S sub 2 is equal to 700 milliliters. Plugging this in right up here, you get S sub 10 is going to equal to the 14 minus the 700. So the S sub 10 is going to equal to 700 milliliters. Sorry, it's been a long few days. Alright, your homework is right down here. 222, you're going to do all the practices 1 and 2. That's why I say practice through 2. 6 through 11, 14 through 16, and then 3 more of your choice. Text me if you have any questions. I know you're going to do awesome.